Hello, ladies and gentlemen, and a very warm welcome to everyone who is joining us today. My name is Eleanor Cody Flores, and I'm very pleased to welcome you to this STI Forum side event hosted by the International Atomic Energy Agency on the topic Nuclear Technologies in the Fight Against Marine Plastic Pollution, an IAEA initiative. We'll be talking today about how nuclear science and technology can contribute to SDG 14, Life Below Water. And as I'm sure you're aware, this is one of the topics that this year's STI Forum will be examining. Before we really begin, I'd like to go through a couple of small housekeeping issues. First of all, we are recording this meeting. We've muted all the microphones and we've disabled video for our participants as we want to ensure a more stable platform. We will have a question and answer session at the end of the panel discussion. And if you'd like to ask a question, please type it into the question and answer box on your screen. Our speakers and panelists today are Martin Kraus, Director of the Division of Program Support and Coordination in the Department of Technical Cooperation at the IAEA, together with our colleagues Florence Decroix-Comanducci, who is Director of the IAEA Marine Environment Laboratories, and Marc Metian, a research scientist in the Radio Ecology Lab of the Marine Environment Laboratories. I'm also delighted to welcome our two guest panelists, Dr. Ana Carolina Ruiz Fernandez and Dr. Hideshige Takada. Dr. Ruiz Fernandez is a researcher at the Institute of Marine Sciences and Limnology, the National Autonomous University of Mexico, and she's also a member of the executive committee of the Remarca network, and she'll be talking to us a little bit more about that later on. Dr. Takada is the professor of environmental chemistry of organic micropollutants at Tokyo University of Agriculture and Technology. And you're all very, very welcome. Thank you for joining us. I would like particularly to thank our two external panelists who are speaking to us across time zones, very early and very late. They are 12 hours apart from each other, and we very much appreciate their willingness to participate here. I'd like to start by giving the floor to Martin, our director, who will be speaking about the challenges posed by plastic pollution. Martin.
Thank you, Eleanor, and hello, everybody. The topic of this side event is marine plastic pollution and nuclear technologies. You might be wondering, how does that go together? What is the connection? Nuclear is not normally associated with environmental issues or with marine plastic pollution. What we do know is that plastic pollution has become a real massive global problem, a global challenge. You need to look at the media reports that we are all, following, and there are articles, there are videos. There is awareness raising about global plastic pollution everywhere. Plastic, when it is wasted, when it is discarded, ends up in landfills. It harms our ecosystems and our natural resources. Out of the total plastic that is being produced, only 9% is being recycled. What does that mean? That means 91% of the plastic ends up somewhere. And often it is being broken down through chemical processes into microplastics. It's being swept away from the landfills or from wherever it is to the rivers and ends up in the oceans. It is estimated that somewhere between 1.1 and 8.8 million tons of plastic waste enters the ocean from the coastal communities each year. As of 2020, the global mass of produced plastic exceeds the biomass of all land and marine animals combined. It's very hard to imagine those volumes, but if you have followed the media reports in the last months and years, you can picture what that means. Around 80% of all the marine litter is actually plastic litter. Plastic pollution is one of the major environmental issues of this century. It greatly affects land, waterways, oceans, and the marine life. And UNEP and the international community have launched actually the formulation of a new global convention, a global treaty, an agreement, something that that hopefully will come into place in a few years from now to curb this problem of plastic pollution. Let me also say that actions against plastic pollution at whatever level will only work if the full range of technologies and technological solutions are being applied. And here we are coming back to the very beginning, and this also includes nuclear technologies and nuclear techniques. Those techniques, and this is what we will hear about in this side event, they are not there to replace other approaches. They are meant to complement traditional approaches. The challenge, we believe, is simply too big to miss out on innovative technologies that could add real value to the ongoing efforts and initiatives. We need to know more about this, and this is now where the IAEA and our side event comes in. Back to you, Eleanor.
Thank you very much, Martin. Indeed, that is a shocking, shocking statistic that 91% of plastics are not recycled and that 80% of the plastic waste ends up in the oceans. It's truly shocking. Before we move into the specifics of this side event, marine-based pollution, we'd like to show a video on how nuclear science can be used to assess the state of ocean health. We're going to go to the video now. Thank you.
Oceans. They cover 71% of the planet's surface, host the majority of its biodiversity, and produce more than half of its oxygen. A healthy ocean is vital for a healthy planet. But the impacts of human activities are causing widespread ocean changes. These threaten ocean life and the livelihoods of more than 1 billion people. Nuclear applications are helping us understand and mitigate these major environmental challenges, especially ocean acidification and pollution. Greenhouse gas emissions are increasing the acidity of our oceans and corroding fragile marine life. To better understand and measure these impacts, scientists are using the calcium-45 radioactive tracer technique. They set up experimental aquaria with seawater at different pH levels and add calcium-45 as a tracer to measure the difference in the growth of corals and shellfish. Gathering this data is vital to protecting the health of coral reefs, which are so critical to marine ecosystems and coastal communities. Today, people are facing dangerous levels of contaminants in their seafood, from heavy metals, pesticides, microplastics, and more. Using techniques based on mass spectrometry, scientists are able to identify the level and source of pollutants in seafood. When analyzing a sample, they remove all its organic matter, leaving only the contaminants behind, and then use specialized analytical instruments to determine contaminants present in the sample. Having this data helps coastal countries make appropriate management decisions to regulate pollution. These nuclear and nuclear-derived techniques provide a unique window into understanding the processes behind ocean change, an understanding that can help us secure a healthy ocean for the future.
This video gives an overview of how nuclear science and technology can be used to address pollution challenges in the ocean overall. But what we're going to focus on today is plastic pollution. And I'd like to ask you, Martin, the agency has embarked on an ambitious project to bring people around the world to address plastic pollution and to help improve ocean health. Can you tell us something about this new initiative?
Yes, thank you, Eleanor, for this question. Indeed, I think it was the year 2020 that the IAEA launched a global initiative called Multi-stakeholder. Multi-stakeholder stands for Nuclear Technology for Controlling Plastic Pollution. Now, this is a global initiative that has basically two components. One component is focused on the recycling, and the second component is focused on monitoring the marine plastic pollution. In particular, we are talking about micro and nanoplastic particles in the ocean. So these are the two components. Now, the first component, as I said, on recycling is basically addressing this problem that I mentioned earlier, which is that only 9% of the plastic is recycled. And there are reasons for that. And, we have a technology, a radiation technology that can help to transform plastic waste into usable, high quality resources. And with that, we can reduce the volume of the plastic that ends up ultimately in the rivers and in the ocean. And so that is a very useful addition to the suite of technologies that are being deployed right now in plastic recycling. So that is the first component of the NUTEC Plastic Initiative. The second component is on monitoring the marine plastic waste. Here we are using an isotopic tracing technique, which is a technique that is being used in many other fields and applications, but it can also be used in tracing micro and nanoplastics in the ocean and in the coastal waters. So what will this NUTEC Plastic Initiative actually do? What it will do is, when it comes to the marine component, and this is of course what we are talking about here in our side event, when it comes to the marine component, what it will do is it will help the marine laboratories in the global south to build up the scientific knowledge and the skills and the capacities to monitor plastic pollution in the coastal and in the marine ecosystems. And why is that necessary? Because there is a lack of knowledge of how much plastic is out there in the coastal waters. Where is this plastic coming from? What harm is it doing to the ecosystem and to the fish, for example, and to the fishermen and the fisherwomen? So having precise knowledge of the quantity and the origin of plastic in the ocean is very, very important before we can take actually policy decisions or make recommendations about policy decisions. So in summary, I mean, this initiative was launched because the IAEA, and we also believe that the world needs a transition towards a circular plastic economy. At the same time, it is clear that we need to expand our knowledge and our understanding of the problem before we jump to the solutions. And this data and this knowledge that is being generated by using isotopic tracing techniques can then help to develop effective policies and strategies. So that, in a nutshell, I think describes what the NUTEC Plastic Initiative is all about.
Thank you very much, Martin. So we're talking about a two-pronged attack, if you will. We're talking about a way to reduce it at source, and we're talking about how we can measure the problem once it reaches the oceans so that we can do something about it. You can't address an issue until you actually have data on it. And at this point, I would like to turn to Florence de Crocomanducci, who's the director of the IAEA Environment Laboratories. These labs have a proven track record of conducting applied research and development. They provide training and they provide analytical services, and they're also responsible for transferring proven nuclear techniques to member states in the field of environmental monitoring. But I'm going to ask Florence today to talk to us a little bit about how challenging it can be to identify and track plastic pollution in the oceans. How important is it, Florence, that we monitor marine plastic?
Thank you, Eleanor, and good morning or good afternoon, depending where you are. Monitoring marine plastic pollution is indeed very challenging, even because we are using plastic all the time. Even our monitoring tools are made of plastic, so it's a real challenge. But the information is really essential in order to assess the risk for the marine and the coastal ecosystems. And monitoring marine plastics also help us in understanding the trends, the plastic pollution distribution, not only at the geographical scale, but also at the level of particles. You have to know that the toxicity of plastic depends on the size of the particle, and the smallest particles are the most toxic. So it's really important to have this monitoring approach also at the level of the size of the plastic particles. And these plastic particles are also or can also be associated with other contaminants. So there is here another potential impact on marine biota, which is also adding on the challenge. So as you can understand, we are dealing here with a lot of unknowns, a lot of gaps, still gaps in knowledge regarding the immediate, but also the indirect impact of plastic particles. However, I can say that significant progress has already been made regarding the harmonization of the monitoring and how we gather the data. And this technology can be highly specialized because actually we are dealing with different approaches and specificities. We have here, I'm talking here about chemical engineering, material science, polymer chemistry. And so this requires interdisciplinary teams. And we also sometimes don't know what certain trends or patterns mean. So we need partnership also to interpret the data and the information that we get and we collect. So international cooperation, collaboration is really important here. And so in this context, the IAEA Marine Environment Laboratories which are the very unique and the only UN Marine Environment Laboratories. So we are pushing very hard with partners to provide scientific based information, and also to share this information with our member states. Of course, we are not working together. We're working with the IAEA Technical Cooperation Departments, and in order to build the capacity of our member states to assess the risk that marine plastic can pose to their ecosystems and livelihoods, and while we support the development of global policies and actions for the sustainability of the seas and oceans. And the ultimate objective is to ensure that our member states are able to report on the indicator SDG 14.1 on marine pollution. So we're working towards to facilitate the establishments of a global network of laboratories around the world in our member states that are able to monitor this, in particular the microplastic. And the IAEA laboratories in Monaco will serve as a reference laboratory to provide adapted and validated methods, and also to host training, because capacity building is key in the process. Maybe to summarize, I would like to say that marine plastic pollution represents a global threat. And this is why global monitoring is essential and collaboration is essential. And we, as IAEA Marine Environment Laboratories, have a role to play in helping our member states to generate science-based information, to inform stakeholders, to inform policy, and especially also to support and also to verify the efforts that are undertaken at the upstream level.
Thank you very much, Florence. Martin has already spoken about how nuclear science and technology complements other forms of intervention and technology that are being used to address this kind of pollution. And I think that you've really emphasized that too. I'd like to drill down now more specifically into the kind of role that nuclear technology itself can play. How can nuclear and isotopic techniques be used to monitor plastics in the oceans? What's the special added value of these techniques?
Thank you, Eleanor. It's a good question. As Martin said, we're not working in isolation. Our approach is really complementary to classic techniques. And so the nuclear and isotopic techniques are really used to complement. And in particular, in counting, for example, counting the number of microplastic particles. And with such techniques, we are able to first to characterize the type of plastic pollution particles. So this is the uniqueness of the nuclear and isotopic techniques. We can also track smaller size particles, so below 100 micron, to be very specific. We're also able to assess both the spatial and temporal abundance, and to characterize the marine plastic in order to better understand where they come from. So the sources, and also the transport mechanism with the currents from the source. As you know, when plastic are released or they enter the ocean, you have hot spots, but this pollution can also be dispersed and transported to other areas, even pristine areas. And finally, we can also highlight the historical pollution through the analysis of marine plastic trapped in marine sediments. And the marine sediment can also, unfortunately, serve as legacy pollution, or even source for pollution in the future. So there's a lot that the nuclear and isotopic techniques can bring in complement to classic techniques.
This idea of being able to trace the history of pollutants and to be able to look into the past for very concrete scientific data on how the environment is changing is one of the most exciting things in the work, at least for me. I find it a fascinating part of the work that we do, being able to reconstruct the past to see how things have changed. And in fact, I know that some of our panelists will be talking a little bit about this later on. But before we go into practical examples of how we've been able to apply nuclear science and technology to look at temporal and spatial distribution and to look at size of plastic pollution of microparticles, I'd like to go to Mark, because Mark is working as a research scientist in the radioecology lab, which is really specialized for looking into these kind of challenges. Mark, you're working on ways specifically of tracking plastic pollution. Can you tell me a little bit about how this is being done?
For sure, Eleanor. Thank you for the question. Yeah, so basically, as Florence said, we have a lot of nuclear and isotopic techniques that are used for monitoring purpose, such as more into detail infrared or Raman spectrometry to characterize the plastic particles, or to use, as you said, the geochronological tools to assess the timeline of pollution. In fact, there's a wide range of nuclear techniques that can be used to understand, not limited to that, to the field, the movement, the global currents, and so there's a lot of things that are already ongoing. But when you talk about tracking, it's important to say also it's not only on the field and to verify the monitoring aspect, but also we can understand or assess the impact of microplastic on marine organisms. Basically, here in Monaco, that's what we're doing. In this context, there's other number of marine nuclear and isotopic tools to assess direct or indirect effect. And for example, we can use radio tracer techniques, something that we have an history of doing here in Monaco, to assess how the health of marine organisms are affected by the presence of microplastic in their environment, or to question the role of plastic, as Florence say, they can be a vector of pollutant. And so basically with tracer, we are able to see, is it true, how the quantify this role of plastics as vector of chemical contaminants to marine organisms. You have to know indeed, in fact, that this is directly an important aspect, because right now we have a lot of unknowns, and definitely this is why we are pushing the research and development on this direction. One side is for monitoring, and this is specifically dedicated to transfer our knowledge to member states to be able to monitor plastic, but also to assess the impact or the effect of marine plastic on organisms. Yeah, basically in Monaco, much of our time is dedicated to research and development on the use of these techniques to tackle the question related to marine plastic pollution. We aim to inform member states on the use and to transfer our knowledge and technology, though. So this is really important, and the tracking aspect is key on our work every day.
I think something that's particularly interesting and perhaps not so widely known is the role that these tiny particles can play in acting, as you said, like sponges. It's not just a question, excuse me, it's not just a question of the volume of plastic in the oceans, but it's also what can hitch a lift, so to speak, on these tiny little sponges. We're familiar, I think, with these very detailed photographs of how plastic particles are spread through the bodies of animals and of sea creatures. But I have to tell you that for me, the idea of these as a sort of tiny sponges that can carry other things was a completely new idea to me. The Monaco Lab is very interesting because it not only works on delivering what we call proven technologies that have been used for a long time. We help to build member states' capacities in using these proven technologies, but is also on the cutting edge of research and development. So Mark, I would like to ask you, how are these techniques likely to develop in the near future with regards to monitoring and assessing plastic pollution?
Thank you, Eleanor. Yeah, this is kind of a tricky question. As you know, science and technology are evolving quite rapidly, and definitely, as you said, our role is to really share our knowledge and proven technology to member states, but also we have the role to play to develop these techniques. And at the moment, we are working with partners on different aspects, not proven yet, but we are developing this, including scientists from member states, of course, as a partner, to improve the use of nuclear and isotopic technique in several ways in the context of this marine plastic topic. So right now, we have kind of a series of ideas, and we are developing right now. So for example, in terms of monitoring marine plastic, we are trying to investigate the impact and the pollution with smaller particles. We were talking about 100 microns, which is already low, small size, but now we're trying to go down and down, and so down to even the nanoplastic. And for example, I can tell you tomorrow we have a consultant and experts who will discuss about this aspect of going smaller and smaller, because as Florence said, the smaller they are, the more risk for the organism, on the environment, the ecosystem it is. So this is really one of the aspects that we are pushing for now. We also want to track we talked, to track the plastic particles into the food chain. So, you know, the ecosystem, you have the organism, and it makes a food chain, a food web. And basically, we are collaborating on development of radioplastic or isotopically enriched micro or thinoplastic. Sorry to go into details about the technology, but this is super interesting because to improve the portfolio of current techniques available. And basically, what will bring this is like when you go to the for MRI for medical exams, you go for MRI or a radio scanner that you use in hospitals, and you want to track where a particles or a contaminant is going. So basically, we'll be able to track these microparticles into the fish, and also maybe because, as you know, there's if fish are eaten by other fish and so on, we also see the evolution of these teeny particles into the next trophic level. So this is a kind of a super exciting approach, and we want to develop that here also. Also, one of the other aspects is that we want to go further than what we already do usually. So right now we are trying to assess the impact of plastic on seafood, on marine organisms, and so on. But in the past, we have developed such techniques to try to assess the fate of pollution on human consumer of the seafood. And now we want to adapt this protocol to assess not the risk of contamination to sea for consumer, but adapt this to the risk of contamination by plastic to seafood consumer. This is a way forward. We are a little bit far away from that, but this is one of our targets. And finally, what you need to understand also is right now in terms of experiments to try to assess the fate of microplastic in marine organisms is that people are looking at large levels, not realistic concentration into the aquarium. So they put a lot of plastic, try to see the effect. And this is the way forward with the technique that we have here in the lab. We want to understand with realistic concentration of plastic, what is the fate of this plastic to the organism. And definitely the data generated by member states also, we will use this data to use realistic concentration. So this is like a collaboration back and forth with member states.
Thanks, Mark. It's actually fascinating because what you're talking about, in a way, speaking as a layperson, it's a little bit like nuclear medicine for the sea. Am I right?
Exactly.
Yeah. Because I know that you can use radio tracers in the body, as you've said, to identify cancers, for example, or to identify how the body itself is working, how the processes are working. But you're talking about expanding these to a much greater organism, if you will, which is the sea.
Yeah, exactly. Yeah. This is exactly, we're mimicking what we can do in medicines to try to understand what's going on in our marine organisms. So yeah, definitely.
It's a fascinating side. I have another question for you about the technical cooperation program and the role of the labs with the technical cooperation program. But actually at this stage, I would like to go, I mean, you've spoken about how we would like to help member states generate data. And I would like to go now to Dr. Takada, who has direct, concrete experience of identifying plastic pollution. And I'd like to ask you, Dr. Takada, you've been working on measuring microplastic pollution in Asian waters. Mm-hmm. This is a significant problem, I think. What levels of pollution are you finding? Mm. We have a slide as well that we're going to show. Yep.
Okay, the Asian water is heavily polluted with microplastics. according to the Ministry of Environment, Japan, the East Asian water is 20 times polluted with microplastic than the other ocean in the world. Based on our measurement of smaller microplastics than 300 micron, the levels of microplastic pollution in the water and sediments are close to or even exceeding threshold concentration to cause adverse effects such as inflammation to marine organisms.
Can I ask you what you mean by inflammation in marine organisms?
Mm-hmm.
It enters the food chain, doesn't it?
Yeah, not only entering the food chain, the direct effect of the smaller particles, small microplastic particle to the tissue of the marine organisms. A kind of the immune reaction of the organisms to the xenobiotics.
Thank you. This pollution, we talked a little bit earlier about being able to look into the past.
Mm-hmm.
Have you been able to identify when this kind of pollution started to show itself in the waters of Asia?
Yes, we studied the pollution history of the microplastic by using sediment cores. As the other panelists stated, the pollution history of microplastics is recorded in bottom sediments. According to our measurement of microplastics in sediment cores collected from coastal zones by Asian megacities, such as Tokyo Bay and Manila Bay and Gulf of Thailand near Bangkok, we can say that pollution started in 1960s or 1970s. This means that microplastic pollution started just after the onset of our mass consumption of plastics in our society. To estimate the sedimentation age, we utilized nuclear technology. That is, we measured cesium-137 to determine the layer corresponding to the year 1954 or 1963. So the plastic pollution had started just onset of our mass consumption plastic in our society. So we have to stop it. So we have to reduce the consumption of the plastics.
So in fact, the science that you're using is so detailed that you can practically pinpoint specific years.
Mm-hmm. Yeah.
You have a very detailed slide on screen at the moment. Would you like to describe a little bit more for the layperson what they see on this slide?
So this slide showed the vertical profile of microplastic abundance in sediment cores collected from the coastal zone in Asian megacities. And we have to determine the age of sedimentation of individual layers. To determine the sedimentation age or sedimentation rate, we have to utilize new tech.
When we talk about plastic pollution, is it just in water and in sediment that we find this kind of plastic pollution?
No, as Mark said, the plastic pollution has been spreading to marine organisms too, and even to human beings. As an example, we analyzed microplastics in a kind of bivalves, that is mussels, in Asian waters. This kind of pollution monitoring using mussel is called as mussel watch. And I understand that IAEA is one of the organizers of the International Mussel Watch project. We applied mussel watch approach to microplastic pollution and found microplastic fragments in mussels from Tokyo Bay. We plan to expand our target organisms to benthic bivalves, such as crab, and pelagic fish, such as sardine fish. We again utilize nuclear technology to measure microplastics and associated additives by using gas chromatograph equipped with mass spectrometer. For such measurement, we need the isotopically labeled standards derived from the nuclear technology. Thank you for your attention.
Very much, Dr. Takada. And in fact, what you're saying, it mirrors what Mark mentioned a little bit earlier, that we have applied the approach of International Mussel Watch to microplastics. We're using, or we're recycling technologies, if you will. I don't want to go into a lot of detail now because I see that our time is moving on, but nuclear technology is used to assess, as you saw in the earlier video, nuclear technology is used to assess ocean health in many different ways, including harmful algal blooms. And now these kinds of technologies, we are able to apply versions of them to monitor plastics. Florence spoke about the importance of having harmonized data available, that this is a global problem and that we have to take a global monitoring approach. And at this stage, I would like to turn to our panelist from Mexico, Dr. Ruiz, who is already working on this kind of an approach of bringing people together. Dr. Ruiz, you are a marine researcher, and you're also a member of the executive committee of the Remarco network. Can you tell us about this network? What does it do? What was its mission?
Thank you very much, Eleanor. I'm very honored to be here and to be able to share with you information about Remarco. The Marine Coastal Stressors Research Network, known as Remarco, was born from the collaboration of experts and scientists from Latin American and Caribbean countries, many of us working together for almost 15 years with the support of technical cooperation projects from the International Atomic Energy Agency. The network of experts and scientists agreed on the need for coordinated actions, the exchange of experience, know-how, and data, but overall on the need to align methodologies and practices to ensure comparability of data, to address common challenges and pressing environmental concerns affecting marine and coastal ecosystems, such as ocean acidification, harmful algae blooms, and marine pollution, including microplastics. Remarco mainly builds on South-South cooperation and sets the framework for a new regional cooperation approach to improve the sustainability of the marine and coastal environment. The network was formalized in 2018, and since then it provides a unique space that connects interdisciplinary teams involving scientists, but also communicators, all of them from 18 countries in Latin America and the Caribbean, with two main purposes. The first one is to produce sound scientific information on the status and trends of relevant indicators for the marine coastal environments in our region through the use of advanced methods, including nuclear and isotopic techniques. We have also as a purpose to promote effective transfer of scientific results and evidence-based information to decision makers and communities, in a view to contribute to the definition of public policies to protect our oceans in agreement with the Sustainable Development Goals. Specifically on marine plastic pollution, Remarco aims to improve the regional understanding on sources, distribution, transport, effects, and final destination of microplastics in the coastal areas of the region by using nuclear and derived methods. Evidence-based data is to be shared with the national SDG 14 focal points in a view to support the SDG reporting and strategic decision making. So this is all what we have been working in Remarco since almost 2 decades already.
In fact, Remarco is ahead of the curve because you've been working on it for such a long period of time. You've mentioned that the countries in the Remarco network have been working with the agency for a long time as well. Could you talk to us a little bit about the kind of concrete results that have been achieved through regional cooperation? And how are these concrete results contributing to the achievement of SDG 14?
Okay, I will try to summarize some of the results we have obtained through the time. Well, to start, I would like to mention that we have published guidelines and trained personnel across the region for the sampling and use of sediment cores to reconstruct pollution trends in coastal areas by using nuclear and isotopic techniques like lead-210 and cesium-137 dating, as Professor Takada has mentioned. And one of the main problems in microplastics research is the lack of standardized, harmonized, and fully validated methods. So working side by side, Remarco scientists join expertise to produce harmonized methodologies in Spanish for the region, adapted to the conditions and constraints in a region. And these protocols include from sampling to quantification of microplastics in diverse environmental compartments, including beach sands, seawater, and sediments. We are currently using these protocols, and based on them, and with the support of IAEA for the acquisition of sampling kits, national microplastic monitoring programs are currently implemented in 15 countries of the region. I think this is a very wonderful achievement to have 14 countries working together using the same methodology to provide sound information. Well, the analytical capacity for the chemical identification of the polymers in microplastic is a bottleneck for our research work. It is being enhanced through the transfer of relevant technologies, such as the Fourier transform infrared spectroscopy, to the reference laboratories that provide support to the rest of the countries in the network. Also, joint scientific papers have been published in peer-reviewed journals for dissemination of our findings. And we have in place a communication strategy to ensure that this information is transferred to the decision makers. Finally, the results of the microplastic monitoring program that we have already ongoing are compiled in a regional repository of data at the Remarco's web platform. And this information is to be available to the decision makers and the reporting entities for the specific SDG 14 indicators.
So in fact, this kind of work is contributing directly to member states, to countries' capacities to report on their progress towards the SDG 14, I think specifically target 1. You've mentioned comparable data, and I know that's also something that Florence has mentioned. And this is a case, I think, where South-South cooperation has been a quite strong tool to help develop this set of comparable data. You spoke a little bit about the guidelines for sampling that you have produced and the way that you're working to harmonize protocols in the region. Could I ask you just to repeat briefly the value of having harmonized regional data?
Yes, this is very important because there are a lot of literature about microplastic contamination currently. This is a very hot topic. But when you go to the literature, you can see that you cannot compare the data because some people use one methodology, one type of mesh, one type of a filter to separate the microplastic particles. One use one kind of methodology to observe under the microscope. So it's very different. It's very difficult to say at the end where is the most impacted site and how we can tackle that, because the information is not comparable. So what we are trying to make sure with our strategy is that all the countries use the same methodology. This methodology might not be the same like in other parts of the world, but at least it will allow us to compare and to take sound decisions, appropriate decisions based in this evidence proven data using the same methodology. So we can have better conclusions about what is going on, how much we really receive in these sites, where are the hot spots, where are the most urgent priority sites that we have to protect. So this is the idea, to have the harmonization in the methodology, that we could really have better conclusions, having a same background of information for all the countries that are participating in the project.
And you mentioned already, in fact, that one of the things that Remarco is working towards is having an accessible database of information that can be shared by all these countries. And in fact, that database is, I believe, already accessible, and we will be sharing links to both your institution and to Dr. Takada's institution later on, so that anybody following us will be able to follow also the very specific work that you and Dr. Takada are doing. I have one last question that I'd like to ask you about Remarco, because I'm keeping an eye on the clock.
Yes.
Remarco is an important partner in Latin America and the Caribbean for the agency. What do you have planned for the near future in the area of sustainable solutions for marine plastic pollution? What's next? Okay, I will try to be brief.
First of all, Remarco aims to further consolidate its capacity and encouraging South-South collaboration and technology transfer, including nuclear and derived methods. We intend to continue exchanging experiences and promote peer-to-peer collaboration in Latin America and the Caribbean, but also with other regions. Efforts are currently made to widen our network by positioning Remarco as a strategic partner in international forums and technical working groups. We expect to improve our understanding of the spatial distribution and temporal variations of microplastic contamination in the coastal areas across the region, and use the reconstruction of long-term trends of microplastic contamination by using lead-to-10 dated sediment cores. Remarco is also actively looking to foster partnerships with decision makers to provide them with evidence-based information and on the abundance and impact of microplastic in the coastal areas of our region, to support the design of integrated management programs. We certainly expect to contribute with relevant information on microplastics in coastal ecosystems to track the progress against the SDG indicator 1411B on plastic debris density. And we hope also to do our bit for a more informed and environmentally responsible society through our work on scientific dissemination to the general public.
Martin has mentioned the new UNEP Treaty on Plastics, and he's also spoken briefly about the agency's New Tech Plastics initiative. And listening to what you and Dr. Takada are bringing to that kind of discussion, the volume of information that is already available, and the knowledge across countries, and the capacity to share between countries, this kind of what's generally seen as very specialized knowledge. These are real indications of the importance of global action and partnerships in addressing this global problem of plastic pollution. I would like at this stage to open the floor to any questions, but before I do so, I would like to play a video specifically on the New Tech Plastics initiative. So while we're waiting to look at some of the questions, we'll play the video very quickly. And thank you very much.
Thank you very much.
The IAEA is spearheading an initiative to use radiation in the fight against plastic pollution. It is estimated that by 2050, plastics in the ocean will outweigh fish in the sea. Plastic pollution hinders sustainable development. It threatens ecosystems, imperils food safety, and impacts human health.
Of the many environmental challenges of the day, we can clearly see plastic pollution emerging as one of the most serious ones that we have. As in many other areas, nuclear technologies can be part of the solution.
The IAEA is helping in two ways. First, by using well-established isotopic tracer techniques to track microplastics through different ecosystems. Tracing helps us to understand how microplastics circulate in the atmosphere as well as in water. This can help us devise effective environmental management and mitigation strategies. Additionally, the IAEA is developing innovative recycling methods using electron beams to break down large amounts of plastics and avoid the toxic solvents used in chemical recycling. This will adapt a technology that is currently used to strengthen cables and sterilize medical equipment. We need to reuse and recycle our resources, especially plastics, in order to move away from a disposal culture and towards a circular economy.
There can be no healthy planet without a healthy ocean. And the ocean's health on many fronts is currently in decline.
The IAEA is prepared to be a partner, scientific advisor, and practical partner of member states in facing this very serious challenge.
We've had some questions come in on the readiness of countries to embrace nuclear technology in addressing plastic pollution. And I'd like to open that question to Mark, if I might. How much training is necessary to prepare national counterparts for marine monitoring? Mark, may I give you that question?
Yes, no problem. Thank you for this question. Well, it's tricky question, by the way, but basically depends on the level you're starting from. So basically, our strategy, or with our countries and with our member states, is basically, first of all, we assess the level where they are at the current, when they want to start working on this plastic. So, for example, if you start from scratch, you don't have any expertise on marine plastic, this is not a big deal. We just step one, and we try to help you during, for example, you talk about duration, a year, to be able to address SDG 14.1 point, and basically you will be able to have appropriate methodology, familiarize with this tools, and we'll put you in connection with other labs in the region, ideally, and basically we can push for that. Then after, we talked about a lot of nuclear technology today about related to plastic. Then if you want to go further and try to, for example, characterize the type of plastic, date the trends of pollution in your country, then it takes definitely much more time. So let's say the first approach for characterizing, it's also including procurement, trainings, fellowships, and so on, could take definitely an extra years. And then after, it can go further and further. But the idea is to basically adapt to the needs and basically provide a portfolio of different options. And with time, and of course, we are willing to have this approach of sustainability. So basically, when we provide or build capacity, definitely it's in a sustainable way.
Thanks, Mark. And in fact, from what we've heard from Dr. Ruiz and Dr. Takada, there's already a significant body of regional expertise available in this field. Another thing that we've been asked, and I'd like to give this question to Martin, is Mark has talked about the steps a country might need to go through. What kind of support does the agency provide to these countries, and how?
Yeah, thank you, Eleanor. And you know what Mark has spoken about, building up the capacity of the marine laboratories across the globe is indeed something that we as the IAEA, through our technical cooperation program, are engaged in. We are supporting countries. We are supporting marine labs, which are sometimes hosted by university, let's say, or by research institutions in the global south. We are supporting those marine labs with a range of services that we offer. For example, fellowships, training, procurement of equipment. When it comes to harmonized protocols, what Anna was talking about, you know, it's very important to bring people together from different labs. Some are more advanced in terms of their skills and capacity and knowledge, and others are less advanced. To bring them together at a regional workshop is something that is being supported by the technical cooperation program, something that we do. And that, I think, can help to create a kind of a network like Remarco is doing at a regional basis, but to expand it and have a global network of marine labs that are well equipped, that are well capacitated, that have skilled scientists that know how to use nuclear isotopic tracing techniques, and that is, I think, what all our speakers also have said. That is what is necessary, and that is, I think, where we can step in as the IAEA to help countries to advance on that path.
Thank you, Martin. And there was one additional point that I wanted to ask Florence about, which is about the coordinated research projects that are supported by the agency and the kind of research and development that the laboratories in Monaco are supporting.
Yes, so this coordinated research project, we call them CRPs, it's a very useful tool because it's a way to contribute to, well, by having several research institutes from different member states together to address all together the same question or the same topic is very useful to in order to fill gaps in knowledge, and also it's also a mechanism to bring together more advanced laboratory and least advanced laboratories, and also a way to establish collaboration. So yes.
Thank you very much, Florence. We've now reached the end of our allotted time for this side event, and I am very aware that we are keeping at least one of our panelists up very, very late indeed, because Dr. Takada is joining us from 1 a.m. in Tokyo. Am I correct? So I don't want to impose too much more on our panelists who have joined us. I would like to, however, inform anybody that's watching us that we will share the videos that you've seen on the IAEA TC Twitter account. So if anybody would like to see those videos again, they will be available on the Twitter account. And we're also putting up a slide now to show the Twitter account and the websites of our two external panelists. I'm not sure, Omar, is it up already? We're just showing it now. We'll also share this information on our own Twitter account. So you'll be able to find out more about the work that Dr. Takada is doing in the seas around Asia, and the work that Dr. Ruiz is doing with Remarco. I would like to thank all our panelists, but particularly our external panelists for dedicating their time to this event. We're clearly just scratching the surface of what can be done and what has to be done. But it's consoling to see how much has already been done. And I think we learned today of some very interesting initiatives to harmonize protocols, to harmonize approaches, and to make data available. Please don't hesitate to reach out to us if you would like any additional information on the work of the IAEA and its partners, or if you'd like additional information on the New Tech Plastics initiative. You can find a great deal of information on the agency website and also by following us on our various social media channels. I would like to thank also my own team for all their hard work behind the scenes. And finally, to thank our audience for staying with us throughout this very intense and information-rich session. I thank you all very much indeed for your participation. I hope we've given you some food for thought, and I look forward to a continued discussion. Thank you very much to everybody, and good night.